Welcome back. Bovine Respiratory Disease, or BRD, is the leading natural cause of death in U.S. beef and dairy cattle. Cattleman and Cattleman reporter Brian Baxter has more on an effort from researchers across the country to try and develop new approaches for fighting BRD.
Every cattle producer has dealt with bovine respiratory disease or pneumonia at some point. BRD is the most devastating disease of the U.S. cattle population.
The incidence of BRD in the United States is in weaned calves, on average, is 15 to 20%. In the smaller herds that we have in the U.S., the average herd size in the U.S. is about 50 head. BRD incidence in those cattle will be 30 to 50%. As expensive as medicine has gotten, we've laughed. I can afford to buy the calves, but I got to take a loan out to get the medicine. We talk about the cost of treating calves and how expensive the medicine is, but that's pennies to the dollar for what performance costs you.
BRD is one of those traits that is basically, in terms of genetics, it's sort of our holy grail, if you will, because of the amount of influence that it has on the industry and the cost. It's worth, anywhere from $500,000 to $1 billion a year easily, and those are prices that were developed in the late 90s, so it's probably gotten worse. And can cost anywhere just on treatment from $50 to $120 a head, just trying to control it within.
The sound of BRD is something vets across the country have heard far too often. BRD losses continue despite the development of improved vaccines, new broad-spectrum antibiotics, and increased fundamental knowledge as to the cause of the disease. One of the problems with BRD is the difficulty associated with diagnosing sick animals early in the disease process. Pen writers typically pull and treat animals based on the 4 components of DART, that is, depression, appetite loss, respiratory distress, and elevated temperature. However, clinical signs can be variable due to the many causative agents involved in the disease complex and the temperament of the infected animal. Not all sick animals will display obvious signs of BRD, especially in the early stages of infection when treatment is most likely to be effective.
It's not a disease where we see it in all of the animals. We end up seeing animals that are very sick, very chronic, seem to get it over and over again, but there's a lot of subclinical infection in pens like this where you don't see the BRD. And as a result of that, we end up with economic losses due to decreased gain where the animals are sick and we don't realize it and are never treated for it.
These little critters behind us they're prey animals. And they have millions and millions of years of genetics built in their system to not look sick. Sick and treat doesn't work. You can't reliably find them. Now, can you get better at it? You bet you can. But prevention is where the key is.
To develop new approaches to preventing BRD, a multi-institutional team led by Dr. Jim Womack from Texas A&M University was formed for a 5-year project that includes research, education, and outreach. This BRD Coordinated Agricultural Project, or BRD CAP, is aimed at determining if newly developed genomic tools offer an opportunity to identify DNA markers that can be used to select for cattle that are less susceptible to BRD.
It's a grant that is funded by the USDA National Institute of Food and Agriculture for up to 5 years, conditional on the availability of funding and on the performance of the personnel that are involved in the grant, to study and to translate the results of those studies to the industry, to understand the agents that underlie bovine respiratory disease and the genetic variability among animals for their resistance or susceptibility to the disease. We live in a time that technology is changing almost monthly. Over the last 2 to 3 years, we've been able to develop high-density genotyping assays and there are at least 3 or 4 of them now that have been produced in the market and are commercialized by different companies that allow us to actually look at the DNA of individual animals and ask what is their genotype at between 50,000 to over 800,000 positions within their genome. These are tools that we just haven't had in the past and that enable us to be able to characterize the genetic differences between animals.
This is a really exciting time to be involved in genomics. We've gone in the last decade from doing single gene marker tests to now having the ability to do hundreds of thousands of gene marker tests on a single animal. And basically we're also sequencing animals, and so there's been tremendous developments in genomics, and the idea is to put the power of genomics to tackle the biggest disease problem in the US cattle industry.
To date, there's been no way to directly select cattle that are less susceptible to contracting BRD. However, if a DNA test was developed that could identify cattle that are more likely to remain healthy, this would open up a new approach for selecting cattle.
Disease resistance is quite a hard trait to select for because it's not very heritable, and what I mean by that is there's a lot of environmental factors that play into whether an animal gets sick, whether it gets exposed to a disease agent, for example. So that's a low heritability trait, and low heritability traits are typically pretty hard to improve. However, other animal industries like the dairy industry with mastitis have made genetic progress at still improving milk production and net merit of those animals whilst minimizing the incidence of mastitis. And so there is precedent there that it can be done so long as you've got measurements on animals that you can use to develop selection tools. And that's where we've been lacking in the beef cattle industry. We haven't been able to select for BRD resistance because we haven't had any selection tools that would allow a producer to, for example, pick a bull that might be more resistant to bovine respiratory disease.
We'll be able to build DNA diagnostics that enable producers to identify among their cattle the ones that are more likely to succumb to disease and those that are much more resistant to disease. And of course they can use those animals in selective breeding programs to create genetic improvement for resistance to disease. We'll be able to come up with DNA tests that help us come up with EPDs, molecular EPDs, for resistance or susceptibility to BRD. So these are tools that producers know how to use. They know how to use EPDs to select to improve growth and carcass composition and calving ease within cattle. And we'll also have EPDs now that will tell them the likelihood that the animal or its progeny will get symptoms and be sick from the pathogens that cause BRD, and that in itself will allow selection programs to start increasing the resistance of the national herd to disease, which will be of direct benefit to the animal.
BRD susceptibility is most likely a complex genetic trait governed by the effects of many genes. This means a large number of cattle will need to be studied in order to detect all of the possible genetic variants that are associated with susceptibility to BRD.
When you're talking about doing DNA tests with hundreds of thousands of markers, you need very large populations in order for the statistics to be able to pull out which are those genomic regions of interest. And so the BRD cap is putting together some large discovery populations in both dairy and beef cattle in order to give us the statistical power to actually pull out the regions of the genome that look like they're associated with bovine respiratory disease resistance.
There is also an extension and education component to the project. This will involve the development and delivery of educational programs on animal health management, genomic, and animal breeding programs.
The BRD cap is really a combination of research, extension and education, and all three of those components are vital to the project and very integrated in the project. We have students working in the labs with the research projects that are going on. We're working in close collaboration with commercial operators to actually develop our resource populations, and part of the reason for that is we need such large populations that no university could have the types of numbers numbers we need. And so we're very closely integrated with industry in the discovery, but then also, I think most importantly, the extension component is how do you actually get those tools integrated into industry, incorporated into selection decisions, incorporated into the selection tools that are going to actually be taken up by industry and utilised to make this genetic progress. Because BRD is both environmentally and genetically, there's components of both, it's equally important to concentrate on the management factors that we can implement to reduce stress, ensure animals are in good health and good nutrition, and marry that up to the good genetics to truly reduce the incidence.
If the BRD cap achieves its ultimate goal, then cattle producers throughout the industry will have science-based knowledge and management tools that will dramatically reduce the incidence of BRD.
We have made genetic progress in traits that are lowly heritable, and the value of that genetic progress can be very great for traits like disease resistance, because the cost of this disease to the national herd is over $1 billion annually. So even very small changes that may occur due to selection can have very large economic consequences, which is what makes this research so important.
I think that people that incorporate that into their selection decisions are going to be preferred suppliers, if you will, to the feedlot industry. Of course, there will be savings in reducing the $1 billion cost associated with bovine respiratory disease as it currently exists. And on a more global scale, there will be better animal welfare and less use of antimicrobials in the industry. And both of those, I think, contribute to the overall sustainability of the beef cattle industry.
I'm Brian Baxter reporting for NCBA's Cattleman to Cattleman.
Cattle producers who want to learn more about the BRD cap can go to the project's website at brdcomplex.org. We'll be right back.